A new wave has just begun in the EV industry. Everything seems normal from the outside, but something big is changing inside. Elon Musk recently talked about a rare earth-free motor, and at first glance, it seemed like just a technological update. But the real question isn't whether a motor can be made without rare earth. The real question is what hidden technology lies within it, which could disrupt the entire electric market. Because the truth is, today's entire EV world relies on certain metals, and if a company breaks this dependence, the game won't just be about being cheap or expensive. It will become about control. Who will make it? How fast? And who will be left behind? Whispers have already begun within the industry. Is this just a new motor or the biggest technological shift of the future? So, how is Tesla's move forcing Toyota to reconsider? And why could it disrupt the electric market in the future? What follows in this video may make you see the future of EVs in a completely new light. So, be sure to stay tuned until the end. Before continuing, please subscribe to the channel to be the first to see more videos like this. Before we understand Tesla's new motor, let's understand Tesla a little. Today, when we hear the name Tesla, we think of futuristic cars, automation, and a company at the forefront of technology. But there was a time when people smiled at the name Tesla. They thought no one could change the world by building an electric car. And Elon Musk, people considered him a wealthy dreamer, burning money on impossible things like rockets and electric cars. But Tesla was founded in 2003 by Martin Eberhard and Mark Tarpenning. Their dream at the time was to create a car that would run without gasoline yet be as fast and stylish as a sports car. Elon Musk wasn't the company's founder at the time, but in 2004, he invested in it and gradually became the company's face. Back then, the word EV was used to describe a slow, ugly, and useless car. But Tesla delivered its first blow with the Roadster, which arrived in 2008. It was the first electric sports car, capable of a 0 to 100 kilometers per hour sprint in just 4 seconds. But in truth, it was more the beginning of struggle than success. 2008 was almost the end for Tesla. The company was running out of money, facing production problems, and investors were backing out. At that time, Elon Musk invested a significant portion of his personal wealth into the company, and many considered it crazy. But Musk didn't give up. Then in 2012, the Model S arrived, and this is where Tesla began to surprise the world. It wasn't just an electric car, but a luxury, long-range, and high-performance car. For the first time, people realized that electric vehicles could be the future. After that, Tesla never looked back. The Model X arrived in 2015, followed by the Model 3 in 2017, bringing Tesla to the masses. The Model 3 marked Tesla's entry into the mass market for the first time. Then came the Model Y, which solidified Tesla's position in the SUV segment. Today, Tesla is known not just as a car company, but as a tech company. Now, let's talk about how many cars Tesla sells each year. In 2015, Tesla sold approximately 50,000 vehicles. In 2020, Tesla sold approximately 500,000 vehicles, and growth accelerated from there. See, in 2021, this number reached 936,000. In 2022, Tesla sold approximately 1.31 million cars. In 2023, this figure increased to approximately 1.8 million. This means that a company that people used to laugh at is now selling millions of vehicles worldwide every year. Tesla didn't just sell cars, it made EVs cool. It demonstrated that electric cars aren't slow or weak. The supercharger, network, software updates, autopilot, all of these have set Tesla apart. Today, Tesla is present in many major markets around the world: the United States, Europe, and China. Thanks to the gigafactories, it's rapidly ramping up production. And that's why when Elon Musk talks about rare earth-free motors, people don't take him lightly. The real weakness of the EV industry. From the outside, the EV industry seems like a glimpse into a futuristic world. Silent cars, fuel-free travel, screen-controlled machines, everything seems as if the future has just arrived. But beneath this shiny surface lies a reality that's not often discussed, and that truth is a heavy dependence on rare earth metals. Most electric cars today have permanent magnets embedded in their motors made from rare earth metals like neodymium and dysprosium. These magnets provide the motor with smooth torque, efficiency, and a compact design. The speed and performance of an EV depend largely on them. But the problem is that these metals aren't available everywhere. Unlike common iron or copper, their supply is limited, and they're not easy to extract. This is where the real weakness begins. When an industry becomes dependent on a limited resource, its costs are not stable. Sometimes prices suddenly rise. Sometimes supply is disrupted. This directly impacts the cost of manufacturing an EV. If rare earth metals become expensive today, the motor will become more expensive. And if the motor becomes more expensive, the car will also become more expensive. This means that the affordability of an EV is directly linked to these hidden metals. But it's not just a matter of price. Even more important is geopolitical control. Rare earth mining in the world is concentrated in a few places. This means that supply isn't just governed by market rules. It's also influenced by politics. If supply decreases for any reason or exports are banned, the entire EV industry could be affected. This is why the EV industry is quietly vulnerable today. While everything appears strong from the outside, there's a dependency loop that's difficult to break. Companies are working on new battery technologies, but the backbone of the motor still relies on rare earth. Now let's talk about global dependency. Rare earth mining occurs in very few countries in the world. This means that EV companies around the world are dependent on a limited supply chain. This dependency is not just economic, but also strategic. If a country controls rare earth resources, it has an indirect influence on the future of the EV industry. This creates supply chain risk. If mining stops for some reason, logistics are affected or exports are reduced, production could slow down. Companies may have to wait, and the pace of mass production could slow down. Political leverage also becomes a major factor. In countries possessing rare earth resources can influence the global technology industry because EVs are not just vehicles. They are going to become the primary transportation system of the future. And then comes the risk of a production bottleneck. If supply is limited, production is limited. Companies cannot produce EVs on an infinite scale even if they want to, because the materials required for the motors are limited. This is why the future of EVs is not as secure as it appears from the outside. Technology is advancing, but its roots are still tied to a resource that is not completely stable, and this hidden weakness could be the source of the greatest change in the future. When Elon Musk talked about a rare earth-free motor, it seemed at first glance like a cost-cutting effort, as if the company wanted to make the motor cheaper. But a closer look reveals more than just a cost-cutting story. It could signal a major shift because eliminating the rare earth dependency on which today's EV industry relies is no easy task. Creating this motor isn't just an engineering challenge, but also an attempt to free up the supply chain. That is, if the motor is made without rare earths, companies will no longer be dependent on limited resources whose supply can be disrupted at any time. This is where this move becomes strategic. If Tesla truly succeeds in achieving a rare earth-free motor, it will mean it will be less dependent on the global supply chains on which the rest of the industry still relies. This could lead to more stable production planning in the future without the fear that certain materials will suddenly become expensive or scarce. An evolution of motor technology. If we look back at the story of EV motors, we understand that this technology didn't arrive here overnight. It's been a journey, and each milestone has propelled the industry forward. Initially, most electric cars used permanent magnet motors. These motors could deliver high power in a small size, and their efficiency was also excellent. This quickly led to their popularity. But as we discussed earlier, these motors had a major weakness, a dependence on rare earth metals. This meant they provided power but also carried supply risks and cost uncertainty. This is where Tesla chose a slightly different approach. The company used induction motors, especially in its initial Model S and Model X. Induction motors don't rely on rare earth magnets. They generate the magnetic field electrically, and meaning there are no permanent magnets inside. This had the advantage of avoiding rare earth dependency. But it also had its own challenges. Induction motors are generally less efficient and may require more energy to achieve high performance. Despite this, Tesla demonstrated that induction motors can be powerful. This was the reason why people first saw that EVs could be fast and efficient even without permanent magnets. But the story didn't end there. As the EV industry progressed, companies began trying to find a balance between efficiency and performance. Permanent magnet motors returned in some places while induction continued in others. And now the industry seems to be at a new turning point. The move towards hybrid motor concepts. The new thinking is, why should motors rely solely on a single technology? Can a system be created that balances the freedom of induction and the efficiency of a permanent magnet? This is the direction in which next-generation motor technology is now developing. Tesla has experimented with breaking away from conventional paths before. It played a major role in bringing induction motors into the mainstream. Now, talk of rare earth-free motors is being seen as the next step in that journey, as if the company is rethinking the fundamentals of motor design. Hidden technology. Now the story reaches a point where things get a little interesting because a rare earth-free motor doesn't just mean removing some metal from the inside. The real change may be in the way the motor works. Most motors today are equipped with permanent magnets, which constantly maintain a constant magnetic field. This field helps the motor rotate. But if there are no magnets, how will the motor rotate? This is where a new approach begins. An electromagnetic design shift. A new direction could be to create a controlled magnetic field instead of a permanent magnetic field. That is, the field within the motor can be dynamically generated, and it should be possible to vary it according to need. This means that the motor will no longer be a fixed system but can become a responsive system. But it's not just a hardware game. Software plays a major role here. Smart control software can manage the motor's behavior in real time. When and how much torque is needed, how much power to apply at what speed. All this can be managed through software. This means the motor will be powered not just by electricity but also by algorithms. Then comes advanced torque management. In traditional motors, the flow of torque is largely constant because the magnets perform their work continuously. But if the field is generated dynamically, torque can be controlled more precisely, more power when needed and less at light loads. This can improve efficiency. This means that rare earth magnets could be replaced by a system based on field control. This system would operate on electrically controlled fields instead of permanent magnets. This could make the motor's behavior more flexible. The most interesting thing is that this change will not be visible from the outside. The car will remain the same. The sound will remain the same. The speed will remain the same, but the internal mechanism may change. And perhaps this is the hidden technology that could make rare earth-free motors not just a change, but a new direction. Impact on competitors. If a rare earth-free motor truly succeeds, its impact won't be limited to Tesla. It could directly impact all companies that have based their EV motor designs on permanent magnets like Toyota, BYD, and many legacy automakers. Today, these companies have built their EV architectures around the idea that rare earth magnets will be an essential part of the motor. Their supply chains, manufacturing setups, and designs are all designed accordingly. But if a motor system emerges that can deliver high performance without the need for rare earth, it could challenge the entire design logic. Imagine if Tesla's model succeeds, but other companies will be faced with the question, should they continue with their current motor designs or change direction entirely? Because if a rare earth-free system proves to be cheap, scalable, and stable, the old design will gradually become less attractive. This would mean that existing motor designs could face the risk of becoming obsolete. Systems that were considered industry standard until now could suddenly appear obsolete. And this change won't just be about technology. It'll be about manufacturing strategy as well, because changing motor design means changing production lines, supply chains, and testing processes. This means companies may have to rethink their entire manufacturing model. This could be even more challenging for legacy automakers because their systems are large, complex, and long established. A change isn't easy. Companies based on innovative thinking can change direction more quickly. So rare earth-free motors could become not just a new technology, but a potential pressure forcing the rest of the industry to rethink. If this happens, EV competition won't be just about batteries and range, but motor design could also become a new battleground. Energy efficiency trade-off mystery. Now the story reaches a turning point where the biggest question arises. If the rare earth magnets are removed, will the motor's performance be affected? That is, will efficiency decrease? Will the car's speed or range be affected? This is the mystery of the energy efficiency trade-off. Because the greatest strength of permanent magnet motors is that they can do more work with less energy. The rare earth magnets embedded within them constantly maintain a strong magnetic field, eliminating the need for the motor to repeatedly expend additional energy to create the field. This is why these motors are considered very efficient. Now, if these magnets are removed and a field control-based system is adopted, the motor will have to generate the magnetic field electrically. This means that some additional energy may be consumed. This is where the engineering challenge begins. This is where Elon Musk's claim becomes interesting. He has been suggesting that the new motor is attempting to remove the rare earth dependency without sacrificing performance. This means the goal isn't just freedom, but also equal performance. But this isn't an easy task. If the motor has to constantly generate a field, efficiency could decline. And in EVs, that efficiency directly impacts range. This means even a slight decrease can impact driving distance. This is where smart software optimization comes into play. New generation motors won't rely solely on hardware. Instead, software will balance it. When to generate a field, when to reduce it, when to increase torque, when to decrease it. All of this can be managed in real time. This will allow the motor to consume energy only as needed, not constantly. This means that balancing efficiency can be achieved through software. This means the real game may not be magnets versus electricity, but hardware versus intelligence. And this leads us to the next big change, the future market shift. Until now, the main battleground of EV competition has been the battery. Whose battery will last longer? Who will charge faster? Who will cost less? All of this has been at the center. But if motor technology also undergoes a major change, a new frontier of competition could open up. This means that in the future, the EV battle won't just be battery versus battery, but could also become battery versus motor. One company could be ahead in battery design, another in motor design. One could gain an edge in efficiency, another in production scalability. This could shift the balance of the EV industry. Companies that have previously focused on batteries may have to devote equal attention to motor technology. And if motor design begins to impact the cost, scalability, and supply chain of an EV, it could become as important as the battery. This means that in the future, the true strength of an EV could be determined not just by its battery, but also by its motor system. And perhaps this is the change that has the potential to change the direction of the entire competition. Long-term impact. Now, if we think a little further ahead and assume that a rare earth-free motor truly succeeds, its impact won't be limited to technology alone. It could impact the future of the entire EV world. First, let's talk about cost. Why do EVs seem expensive today? Batteries are one reason, but the motor and its associated supply chain also add to costs. The price of rare earth metals isn't constant. Sometimes they rise, sometimes the supply decreases. This directly impacts the overall cost of the vehicle. If the motor doesn't rely on rare earth, a significant expense could be reduced. This doesn't mean the car will suddenly become cheaper, but it could pave the way for a gradual cost reduction. And this is where a major change could become possible. The dream of a $20,000 EV. Today, most electric cars are a bit out of reach for the average person. But if motor technology becomes affordable and scalable, it could become easier to build a low-cost EV, meaning a car that's as economical as a petrol car. These three things could together give a new direction to EV adoption. And if this happens, rare earth-free motors won't just be a technological improvement. They could pave the way for EVs to reach the common man. If technologies like rare earth-free motors truly succeed on a large scale, their impact won't be limited to just one company or a few vehicles. They could impact the entire global market. Today, the EV industry stands at a balance. Some countries are technologically advanced, some have a strong hold on the supply chain, and some are fast at manufacturing. Rare earth metals play a major role in this balance. Countries that possess these resources also have an indirect influence on EV production. But if motors are developed that don't require rare earth, this balance could change. The primary impact will be on the supply chain. Currently, many companies source materials from a limited source. But if motors can be made without these metals, production will become possible in more locations. This means that EV manufacturing will no longer be limited to a few countries. This could change the manufacturing landscape. New companies, new regions, and new markets could enter EV production because they no longer have to deal with the complexities of rare earth sourcing. Then comes the issue of price competition. If some companies are able to produce affordable vehicles with rare earth-free motors, other companies will be pressured to reduce prices. This could intensify price competition in the global market. This will especially impact markets where consumers are price-sensitive, such as Asia or Africa and Latin America. So far, EVs have grown rapidly primarily in developed countries. But if costs decrease, new markets could open up. This will also increase technology competition. Until now, companies have been striving to gain an edge in batteries. But if motor technology also begins to make a significant difference, a new era of innovation could begin. Companies will focus not just on range or charging speed, but also on motor efficiency and scalability. This could also shift investment trends. Whereas previously investments were focused on rare earth mining and related supply chains, investments could now be focused on new motor designs, software controls, and manufacturing innovation.